All right, so here we will discuss finding a polynomial function with the given zeros. An example, we have find a fourth degree polynomial function with real coefficients that has -2, 2, and I as zeros, in other words, as solutions. And f of 3 is equal to -150. That's the initial condition that when I plug 3 into my function, I should get out -150. So we talked about before how if you have a fourth degree polynomial, a third degree polynomial, second degree polynomial, that lets you know how many solutions you should receive, even if there's a repeated value. So if I have a fourth degree, that's the highest degree of my polynomial, I should have 4 solutions. Notice they give me 3. They give me -1, 2, and I. But according to the complex conjugate theorem, that says that if A plus BI is a solution, that means that A minus BI is also a solution. So here are just a few examples of complex conjugates. All you're doing is changing the sign in the middle or the sign that's given to your complex part. So 5 plus 7i and 5 minus 7i would be complex conjugates. -1 minus 3i, -1 plus 3i would be complex conjugates as well. So since they gave me I as a solution, that means -I is also a solution. So those are my 4 solutions of my functions. So they gave us the 4 solutions, and they want to know what function would give us or would yield these 4 solutions. So we're going to work backwards. So we're going to, when we go to set up our function, we're going to use A here. We're going to put A just as a random variable to signify that it's possible that there could be a number there. We would do that at the end. But the way we will set up our function, we would do, this will be a minus sign and put a plus sign. So it should be x minus 2, x minus -2, x minus I, and x minus -I. So you're doing all of the opposite of signs of your solutions. Because remember, what would happen is if I have x minus 2 as a factor, when I go to solve, I will add 2 to both sides, and then that will give me +2 as a solution. If I have x plus 2 equal to 0, I will subtract 2 from both sides, and that will give me -2 as a solution. So that's what's going to happen here. When they give you the solutions, when you go to put it back and set it up as a function, you will use minus whatever that solution is. So once again, minus +2, minus -2, minus I, and minus -I is how you will set it up. Then from there, we will look to simplify. X minus 2, -2, turns positive, so it's x plus 2. And the same thing happened with our i's. Then from there, we can go ahead and multiply, do our binomial distribution. I will go ahead and multiply the x minus 2 and x plus 2 together first, and multiply x minus I and x plus I together. Here, since they're conjugates, they're going to cancel out. And I did the binomial distribution over here, so you can see the cancellation in both cases. So that'll give me x squared minus 4, x squared plus 1. Go ahead and distribute there. X squared times x squared to give me x to the 4th. X squared times 1 is x squared. -4 times x squared is -4x squared. -4 times 1 is -4. Combine your like terms in the middle, and that gives me -3x squared in the middle. So now we have f of x is equal to a times x to the 4th minus 3x squared minus 4. So in order to figure out what is a, we use that initial condition that when I plug in 3, I should get out -150. So I plug in 3 wherever I see x and set it equal to -150. So 3 to the 4th is 81. Here we have 3 times 3 squared. That 3 squared is 9. 3 times 9 is 27. 81 minus 27 minus 4 will be 50. So I have 50a equal to -150. Divide by 50 on both sides, of course, and then a is equal to -3. So now that I have a is equal to -3, I can plug -3 in for a, do my distribution, and I'm left with f of x is equal to -3x to the 4th plus 9x squared plus 12. And that function right there would satisfy the initial conditions and the solutions of -2, 2, I, and -I. Let me know if you have any questions.